Whew, did those jumping jacks. Got some more coffee. Woohoo, like I needed it. I'm ready to go. Take out the sheet for this week. That is going to start out with, this is, what's the date? April. I was saying September. Either I'm way behind or way ahead. April 29th. April 29th, okay? And you're going to look at that and you'll see balance the following redox reactions. Balance the following. Actually, this would have been on last week, so I never combined them the way I did, but this should be on last week's, April 22nd, if I remember correctly. I had some redox reactions on the bottom of that sheet. On this one, I move them to the top because I kind of mix everything up at the end of the course. But find the redox reactions either on the bottom of April 22nd or the top of April 29th. Do it, people. Find them. And you'll see there are 5 reactions to balance. Well, I'm going to do 2 of them. Just 2. I'm not going to go through, trust me, after I do 2 of them, you're going to say, please, no more. No more, sir. Please, may I have no more? Okay, that's what you'll be saying. So I'm going to start out with B, 1B. Do A. Nah, actually I wrote this out and I discovered, I realized that I put peroxide in there, and that can be a little tricky to start out with. It might be a little more difficult. So I'm not going to do A, I'll do B first. B's actually a little easier. And so here it is. This is B, written out on the board behind me. Okay, we need to balance this. So the first thing I do, so where should I write this so you can see it? Over here. Okay. You with me? Number 1. Write the charges of the elements on each side. Write charges. Now I'm going to have to write this small, so you may not be able to read it, but doggone it, I'll say it one more time. Write the charges. Write charges of each element on each side of the reaction. Okay. What's the charge of copper atom? Doesn't have one. It's a copper atom. It's not an ion. An ion has a charge. Copper atom doesn't have a charge. It's the 0. So I'm going to write that charge here. 0 doesn't have a charge. It's copper atom. What you're always going to be able to depend on is oxygen. You can depend on oxygen always being a -2, unless it's peroxide, which is why I skipped the first one, because in that case, the whole -2, O2 is -1. It's confusing. Don't worry about it. This oxygen is always a -2 charge. -2. The other thing you can count on is hydrogen. Hydrogen is going to be a +1. It will be this is what hydrogen is, a +1. Count on it. So hydrogen is a +1. So I've written the charge of the oxygen. It's a -2. It always is. Hydrogen is always a +1. Now here's what we've got. This is, if you actually might recognize this, I hope you do, that's nitric acid. Okay, HNO3 is nitric acid. And this is not an ion. This is a compound, which means the charges of everything together are all neutral. So the negatives and the positives are balanced within the compound. Now if I take -2, the charge of 1 oxygen, and multiply it by 3, somebody got the calculator? Do the math. -2 times 3, I'll wait. Thank you. Thank you, Mikey. That is -6. So the total charge of the oxygen in this compound is -6. We have 1 hydrogen, and it's a +1. Well, +1 times 1 is 1. This is a balanced compound. What does that mean the charge of nitrogen has to be? -6, +1. Must be balanced, have no charge. I need a +5 here. This 1 nitrogen must be using a +5 charge. Nitrogen will usually use a -3 if it's at the end of a compound. All right, if it's the one on the right, going to use a -3, but it can use other charges, nitrogen can. And here's a case where the nitrogen would be using a +5. This total positive charge is +6. It has to balance the -2 times 3 or the -6 of the oxygen. This compound doesn't have any charge to it. So it's a nice electrically neutral compound. That means the negatives and the positive must balance. -6 must be balanced by +6. The hydrogen is only a +1. The nitrogen must make up the rest of the positive charge with a positive 5. Okay, so I'm going to put that up top, positive 5. That doesn't make sense. Rewind. Okay, we got those on the left. Right charges of each element. Did it on the left. Let's do it on the right. This copper is already done for me. It told me right in the reaction I have a copper positive 2 charge. Okay, oxygen. Always a negative 2. Negative 2. There's 1. This is nitrogen monoxide. You have 1 oxygen. It's a negative 2 charge. What does the nitrogen have to do to balance that? Remember, these things have to be electrically neutral, unless they're a polyatomic ion, okay, which means you got a compound with a charge, ion. These are compounds. They're not electrically charged. They're electrically neutral. So negative 2, oxygen always, positive 2. The nitrogen must have a positive 2 charge that it's using in that compound. The nitrogen's changed. Oxygen, always negative 2. Hydrogen's a positive 1, always. Positive 1 times 2 is positive 2. That makes sense. H2O is water. You know that. And it's nice and balanced, electrically balanced. So we have a positive, well, actually, what I should do here is make that positive 1. And there are 2 of them, which gives me my electrical neutrality. So now that what we've done is we wrote out the charges of each one of the reactants and products. Okay, we had to use a little bit of chemistry knowledge to do that. That's one of the things that makes these more difficult for students. We're going back to pulling back some chemistry knowledge about things, and I don't want to do that. I never promised you a rose garden, people, okay? Here we go. Step 1, done. Step 2. Step 2 is to identify who got oxidized. I'll just put OX positive, OX period, and who got reduced. Okay, identify who got oxidized and who got reduced. We should be able to do this now. We just went through what it means to be oxidized and what it means to be reduced. Let's do it. Remember, in order to be oxidized or reduced, you change. Your oxidation number, your positive or negative, has changed somehow. Copper, it went from a 0 to a positive 2. That changed. Something happened there. That's either an oxidation or a reduction. Let's check out the hydrogen. Positive 1, positive 1. No change. Nope, you're not it. Oxygen, negative 2, negative 2, negative 2. Oxygen, nope, not it. You did not undergo oxidation or reduction. Nitrogen, positive 5, positive 2. You changed. We have 2 things that changed. Remember, we're going to have something oxidized and something reduced. We've got 2 things which have undergone change. Okay, who got oxidized, who got reduced? Copper went from a 0 to a positive 2. Its oxidation number went up. It lost electrons. That's oxidation. Nitrogen went from a positive 5 to a positive 2. Its oxidation number went down. It got lower. Positive 5 is higher than positive 2. So the oxidation number went from positive 5 to positive 2, went down. Therefore, that's reduction. Its oxidation number went down, got reduced. Boom, identified them. Okay, now we know that. Gotta keep that in mind. Step 3. Write the half reactions. Write the half reactions. That means the oxidation reaction, and that means the reduction reactions. Half reactions because we have half of the total reaction. Somebody got oxidized, somebody got reduced. So together, that makes a whole reaction. So each one of them, oxidation reduction, is a half reaction. Okay, so I like putting the oxidation reaction above the reduction reaction, just me, whatever. So let's write the oxidation. What underwent oxidation? The copper did. It went from a 0 to positive 2. That is the oxidation. Let's write that reaction. Okay, so how do I do that? Copper went from 0 to copper 2 plus. Copper on the left, copper on the right, 0 to 2 plus. But in order to do this, it gave away 2 electrons. So it kicked out, punt, twice 2 electrons. So 2 electrons got kicked out. So 2 electrons. And so when you undergo an oxidation reaction, you write the half reaction, put the electrons, which got booted out, as a product, because they got produced, they got released. So these are on the right, those 2 electrons that we booted out. Reduction reaction. Who got reduced? Whose number went down? The nitrogen. But we have to put the whole compound. The nitrogen, we can't just put nitrogen. We have to put the whole compound that nitrogen is in. So write down the compound, HNO3. Okay, with a reduction reaction, we added electrons. You don't go from +5 to +2 without gaining electrons. You gain 3 electrons to do that. +5 to +2, I added 3 electrons, which made my number go down. I got reduced, so I added those electrons. Those go on the reactant side. When you add electrons, they are part of what's going to make the new compound. So the reduction, we put the electrons on the left, the reactant side. How many? +5 to +2? 3. So +3 electrons on the reactant side of the reduction half reaction. For this one, I mean, for a different reaction, of course, it could be completely different. You might add 1 electron, 2 electrons, or whatever. But for this reaction, we added 3. Okay, what about on the right? The nitrogen is here in the nitrogen monoxide. So there it is, the nitrogen monoxide. So we went from here to there. So we're not worried about the hydrogen and a couple of oxygens. What happened to those right now? We'll deal with those. But for now, you just write the nitrogen in the compound it was in, the nitrogen in the compound it's now in, and you add your electrons that got that nitrogen from +5 to +3, or +2. So we added 3 electrons. Those are the half reactions. All right? Next step, balance the electrons. Step 4, balance the, balance the electrons. Balance the electrons, what do you mean? Well, take a look at this. If the electrons 2 and 3 aren't balanced, we're going to balance them. So right now I have 2 electrons in this half reaction and 3 in this half reaction. Those aren't equal. We need those reactions. We need these to be equal. So remember, this whole point of balancing this equation is not making sure that everything is balanced, but the charges have to be balanced. So I have to balance these electrons. So how do I do that? Well, just to go back to thinking about when we balance reactions in Chem 1, or actually in Chem 2 as well. We always balance reactions. That if you have 2 of one thing on one side and 3 of one thing on another side, and that's what we have, 2 electrons on the right, 3 electrons on the left. How do you balance those? Common multiple. What would they both go into? 6, right? They both go into 6. So let's balance these by multiplying this one by 3 and this one by 2. If I multiply this by 3 and this one by 2, I'll have 6 electrons and 6 electrons, and that would balance my electrons. However, I got to multiply everything by 3 and everything by 2. Now I'm going to need some room to do that. You need a lot of room to solve these. You do, and it's just going to be hard. Usually when I do these in class, I'm usually using 2 boards. So what I'm going to do is just turn the camera just a little bit, so hopefully you can see it. Okay. So I'm going to multiply this through and multiply this through by 3 and by 2. So that's going to give me, let's see, I'll do this in a different color so it doesn't get all mushed together. Okay. 3 coppers. Arrow. 3 copper plus 2s. Plus 6 electrons. I multiplied this whole half reaction by 3. That balances my electrons. I have to make sure I multiplied this by 3 and this by 3. Did it. Same thing here, but I'm going to multiply everything by 2. So 2 times my nitric acid, my HNO3. Okay. Oops. 2 times the electrons are on the left, so those 6 electrons go here on the left of the arrow, and multiply 2 times NO. Nice, I multiplied everything by 2, 6, and 2. All right, electrons are nice and balanced. Next step, how many are there? Oh, wait. I'm gonna turn back this way so we can go back to my steps. Okay, step 5, add the half reactions. Add the half reactions. So now I'm going to add these 2 reactions, these half reactions. I balanced them with the electrons. I add these electron balanced half reactions. Just literally put them back together, So what I'm going to do, let's use this color here, is take these 2 and add them together. Everything on the left of the arrow goes on the left. Everything on the right of the arrows goes on the right. On the left of this arrow, so I'll put an arrow here. On the left of my arrow, I'll put 3 coppers. That's it for this reaction. That's all I have on the left. Here, I've got 2, and left of this arrow, I've got 2 nitric acids. The electrons cancel out. That's what we want. We want those to go bye-bye. That's why we balance them. They actually cancel out. So these, I am not going to put in these half reactions. I mean, you can, but they're going to cancel out. I have 6 on the left, 6 on the right. When you have equal amounts of things on either side of a reaction, then you cancel them out. So they're gone. On the right of this arrow, move this over a little bit, I got room now. On the right of this arrow here, I have 3 coppers. And 2, on the right of this arrow, okay, there's nothing else on the right of this arrow. On the right of this arrow, I've got 2 nitrogen monoxides. Okay, so I've rewritten, so I separated out the oxidation reduction reactions, balanced the electrons, put them back together. Put them back together. You can see this reaction is different than this reaction. I mean, it's the same kind of stuff on the left and on the right, but it doesn't look the same anymore, so we're making some progress here, getting this nice and balanced. Okay, are we done? Are we done? You might be. You could be. You could be done at this point. Fingers crossed, probably not. Usually not, but you could be. Let's see. Well, the coppers seem to kind of balance out, and the hydrogens, oh no, there's no hydrogen over here. No, we're not done yet. So what would I do next if I don't have a balanced reaction at this point after re-putting together these 2 half reactions? Next step, that's what we do. Next step, okay. Got some, okay, there we go. Step 6. All right, now what we're going to do is we're going to add H2O, add water, to balance the oxygen. Add water, H2O, to balance the oxygen. What are you talking about, balance the oxygen? Well, look at the equation. The oxygen is not balanced. I have 6 of them here. Remember, there's a 2 coefficient down here, 2 times 3 is 6 here, and 2 here. It's not balanced. 6 and 2, we've got to balance the oxygen. How do I do that? Add water. Well, you mean you can just add water? Yeah, you can, because these are solutions. Redox reactions are going to take place in solutions. These solutions, how do I know that? It's acidic solution. It says right there, it's acidic, which means it's a solution that this is in water. So there's a lot of water around. So water is going to be water, water everywhere, not a drop to drink. Drink. Rhyme of the Ancient Mariner. We've all read it. Yes, we have. If you haven't, you should go read it right now. Oh, wait. Okay, you back? It's a good poem, wasn't it? Now, add water. How many waters should I add, and where should I add them? 6, 2. We need 4 more waters, or 4 oxygens on this side, which means I have to have 4 waters to that side. Because there's 6 and 2, I need 4 more oxygens. So I balance the oxygen by adding water. Now I'm going to add 4 waters, and I should probably move that over a little bit, a little more room. Plus 4 waters. Check out the oxygen now. Bet it's balanced. 6, 2, and 4 is 6. Balance that oxygen. Woohoo! Can you see something though? Are we done? Are we done? Are we done? We would be if it's balanced. If it's balanced, we're good. Hydrogen. Now the nitrogen right now is all balanced. It's all balanced. Check out the copper's balanced. The nitrogen's balanced 2 and 2. We just balanced our oxygen, 6, 2 and 4 is 6. Check out the hydrogen. If it's balanced, we're good. 2, 8. Not balanced. Now what? Now what? Balance the hydrogen. Okay, how? Okay, last step here. Balance hydrogen by adding hydrogen. If we need hydrogen, we're going to throw it into the equation. You can't just do that. Of course we can. It's an acidic solution. There's hydrogens everywhere. So that's why it's an acidic solution. We have hydrogens. Throw them in there. They're there. Throw some in. Balance it out. So if I now have 2 on this side and 8 on this side, that means I'm short 6 hydrogens on this side. So just add 6 hydrogens and we'll be good. We'll call it a day. So add 6 hydrogens. So 6 hydrogens. Now that was copper. I had 3 coppers here. I just erased it to make room. So there, squeeze that in there. Okay, I just added hydrogen. I can do that because in an acidic solution, hydrogens are there. Throw them in. We're done. We should be done. Finally, it should be done. Oh my God, this took forever. 6. There's 8. 6 but 2 here is it's 8. 3 coppers, 3 coppers. 2 nitrogens, 2 nitrogens. 6, 2, 6. We are done. That's finally balanced. If you were to go through, I'm not going to put you through this torture. It's been 21 minutes so far. These take a long time. I told you you're not going to like this. I told you. That's why I'm not doing all 5 of these. You see? I told you I'd do 2 and be begging me not to do anymore. Actually, this one, after this one, you might be begging me not to do anymore. But I'm going to do 1 more. I will. Okay? If you were to check the charge out, go ahead and total up all the charges of these each one of the atoms and these ions. It should be balanced. It would be balanced. Trust me. Trust me. I'm wearing this shirt. You got to trust me. Okay? Whew, that is just one redox reaction. Told you these are awesome. We'll do another one after a break.